Aaron James was working for a power line company in June 2021 when he was shocked by a live wire. He nearly died. Ultimately, he lost his left arm, requiring a prosthetic. His damaged left eye was so painful it had to be removed. Multiple reconstructive surgeries couldn't repair extensive facial injuries, including his missing nose and lips. James pushed through physical therapy until he was strong enough to escort his daughter, Allie, to a high school homecoming ceremony, wearing a face mask and eye patch. Still, he required breathing and feeding tubes, and longed to smell, taste, and eat solid food again. In his mind and his heart, it's him. So I didn't care that, he didn't have a nose. But I did care that it bothered him, said his wife, Megan James. Face transplants remain rare and risky. James's is only the 19th in the U.S., the 5th Rodriguez has performed. The eye experiment added even more complexity, but James figured he'd be no worse off if the donated eye failed. 3 months after James was placed on the national transplant waiting list, a matching donor was found. Kidneys, a liver, and pancreas from the donor, a man in his 30s, saved 3 other people. During James's 21-hour operation, surgeons added another experimental twist. When they spliced together the donated optic nerve to what remained of James's original, they injected special stem cells from the donor in hopes of spurring its repair. Back in 2023, on a good note, tingles heralded healing facial nerves. James can't yet open the eyelid and wears a patch to protect it. But as Rodriguez pushed on the closed eye, James felt sensation, although on his nose rather than his eyelid, presumably until slow-growing nerves get reoriented. The surgeon also detected subtle movements beginning in muscles around the eye. Then came a closer look. NYU ophthalmologist Dr. Vaide Dadania ran a battery of tests. She found expected damage in the light-sensing retina in the back of the eye. She said it appears to have enough special cells called photoreceptors to do the job of converting light to electrical signals, one step in creating vision. Normally, the optic nerve then would send those signals to the brain to be interpreted. James's optic nerve clearly hasn't healed. Yet when light was flashed into the donated eye during an MRI, the scan recorded some sort of brain signaling that both excited and baffled researchers, although it wasn't the right type for vision and may simply be a fluke, cautioned Dr. Stephen Galletta, NYU's neurology chair. Only time and more study may tell. For Aaron and future patients, let's hope technology continues to advance for the good of mankind.
My name is Eduardo Rodriguez. I'm the Helen L. Kimmel Professor of Reconstructive Plastic Surgery and Chair of the Hans-Jörg Wyss Department of Plastic Surgery at NYU Longone. Although most people think that I just do face transplants, the reality is that most of the issues that I deal with on a daily basis are facial deformities, and they could be from a variety of different forms. Usually they require soft tissue reconstruction of the face, sometimes skeletal reconstruction. The face is not only made of the soft tissue that surrounds the area of the face, but there's also a lot of underlying supportive elements like bone and teeth, and we have to know how to reposition those bones in cases where they're not in the proper position. I think what draws me the most to academic medicine in an institution like NYU Longone is the ability to be part of a team. Each and every one of us brings a unique element, a unique way of thinking, and a unique way of solving a problem. And to have all these individuals at your fingertips in this institution like ours is probably what attracts me the most. There's been a lot of great research that's been pioneered at NYU Longone, and we have benefited greatly. And I think more importantly, our patients have benefited greatly from these tremendous innovations. We look at computerized surgical planning. We can precisely plan the surgical procedure, and we can actually work around designing specific instruments that will be used for this specific operation. In our research lab, we're actually creating experiments that with stem cells, we can grow skin that will also have hair follicles, sweat glands, and even nails. to work in an environment that's so collegial, with the spirit of camaraderie, to solve some of the biggest problems where often we are the last stand for some patients. There's tremendous reward, and it's wonderful to be able to do that at this institution.
The eye, from biology to the world's first whole eye transplant. Our eyes, or the biological camera. To understand why an eye or eyes transplant is so difficult, we first have to understand the eye itself. Like a camera, light enters the eye through the cornea, the clear dome-shaped surface that helps your eye focus, the pupil and iris. The iris is the colored part and acts like a camera shutter, adjusting the size of the pupil to control how much light gets in the lens, located just behind the pupil. The eye lens changes shape to focus light perfectly onto the back of the eye. The retina is like the film of the camera. The retina contains millions of light-sensitive cells, called rods for light, /dark and cones for color. The optic nerve is the most critical part for a transplant. It is a cable made of over 1 million nerve fibers that sends electrical signals from the retina to the brain. Your brain then flips the image right side up so you can see. For decades, surgeons could only transplant the cornea. In May 2023, everything changed. The patient, Aaron James, a 46-year-old military veteran from Arkansas, survived a 7,200-volt electrical accident that caused him to lose his left eye and much of his face. A massive team of over 140 medical professionals at NYU Langone Health performed a 21-hour surgery. They didn't just transplant the eye, they performed a partial face transplant simultaneously. The innovation surgeons used a microvascular bypass to keep blood flowing to the eye and for the first time injected stem cells into the optic nerve during the procedure to encourage the nerves to regrow and connect to the brain. 1 year later, the eye remains viable. While Aaron cannot yet see out of the eye, the retina is receiving blood and the rods and cones have survived, a feat previously thought impossible. Again, science fiction is becoming a reality. Meet Dr. Eduardo Rodriguez, the man behind this medical milestone. Dr. Rodriguez is one of the world's most renowned reconstructive surgeons. Dr. Eduardo Rodriguez is the son of Cuban immigrants and was raised in Miami, Florida. He originally started his career in dentistry, earning a degree from NYU before transitioning to medicine and plastic surgery. He is currently the chair of the Hans-Georg Weiss Department of Plastic Surgery at NYU Langone. He is dual certified in both oral and maxillofacial surgery, as well as plastic surgery. In 2012, he led what was then the most expensive face transplant in history. In 2021, he performed the world's first successful face and double hand transplant. Dr. Rodriguez is known for his methodical approach and focus on philosophy. He describes his work as a blend of many fields: neurobiology, microsurgery, and reconstructive art, aimed at helping those with severe disfigurements return to a normal life. Being able to see from transplanted eyes is the next goal. The bionic eye, fact or fiction? You decide. Only time will tell.